Good day, my amiable viewers. You are welcome back to class. As you all know, my name still remains Israel. In today's class, we are going to be handling some questions in chemistry. These are carefully selected questions. It can be from your JAMB textbook, can be from your JAMB past question, can be from your WAEC past question. The target is to make chemistry very easy for you, so that when you encounter similar questions, you're able to tackle them. Remember, these questions sometimes they are reshuffled. So let's get started. Now the question we have before us. The first question is this one is from JAMB past question. They can also occur in your WAEC, so get used to all of them. Master all. Don't say I'm not writing JAMB or I'm not writing WAEC, so I'm not go through this. Tackle all of them. They are chemistry questions. However, if you still have issues with any, you can always tell me in the comment section, and I will tackle it. How many moles of hydrogen ions are there in 1 dm cube of 0.5 molar solution of H2SO4? To solve this, it's not hard. What you do first, you ionize, make sure this one is in ionic form. Dissociate it. H2SO4, when it ionizes, it forms 2H plus SO4 2 minus. This is the ionic form, it has ionized. So they said how many moles of this are there in H2? So here you have 1 mole. There you have 2 moles of hydrogen ions. You always consult the question, how many moles of hydrogen ions are there in 1 dm cube or 0.5 molar? Remember, 0.5 molar is something as 0.5 mole per dm cube, or 0.5 mole per 1000 cm cube. So let's use the one of dm cube per dm cube, because we are using per dm cube because they say in 1 dm cube. So you now say from the question, from the equation, 1 mole of this is equivalent to, remember, all of them are dm cube. This is dm cube per dm cube, and the question also is in dm cube, so there's no need to convert. 1 mole of H2SO4 is equal to 2 moles of hydrogen ions. Therefore, 0.5 moles or moles, let's use moles, mole of H2SO4. Remember we said 0.5 molar is equivalent to 0.5 mole per dm cube, equivalent to X. The same pattern we will be using, make it very easy for you. You now see S times 1 mole equals 2 moles times 0.5 moles. So you cross multiply. X will now be 2 moles times 0.5 moles over 1 mole. 1 mole. So this one cancel this. You have 2 times this, 1.0 mole. So the number of moles of hydrogen ion in 0.5 molar H2SO4 is 0.1 mole. So this is how you solve this question. Like I still remind you again, get the sheet of paper before you start this class. Try to copy it out so that you can form your own personal note. So that's that. So let's go to the second question. So we have solved this. Go to the second question, number 2. A given mass of gas occupies 2 dm cube at 300 Kelvin. At what temperature will its volume be doubled, keeping the pressure constant? Remember, once the pressure is constant, the law you are going to use, let's take the 2 laws so that you remember. The first law is Boyle's law. Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure if temperature is kept constant. So it's not applicable to this. That P1 V1 equals P2 V2 cannot be used. The one you are going to use is Charles' law. Charles' law states that the volume of a given mass of gas or fixed mass of gas is directly proportional to its absolute temperature if pressure is kept constant. And they told us pressure is kept constant. So the volume V1 over T1 equals V2 over T2. This is what you are going to use, where V1, T1, V2, T2. You are able to put in the values properly, then you will not be able to not have any challenge when you are solving it. The given mass of gas occupies 2 dm cube at 300 Kelvin. So this is 2 dm cube, this is 300 Kelvin. They've helped us by converting it to Kelvin. If it's in Celsius, you must add 273 to get Kelvin before you start calculation. You don't do all this calculation using Celsius. At what temperature will its volume be doubled? So here we have 2V1, which is equal to 4 dm cube. Will its volume be doubled, keeping the pressure constant? We don't have interest in that. So at what temperature? We say substitute. Remember under JAMB, if it's a JAMB class, if it's JAMB exam or objective in WAEC, if you know you'll be fast enough, you can put all the, but you cannot be fast enough, just slot it in directly because it's direct question. Just put 2 here and cancel out. So you have 2 over 300 equals 4. With dm cube anyway, 4 over 4 dm cube, 4 over t. So this is Kelvin, we now cross multiply. We have this temperature, T times 2 dm cube equals 4 dm cube times 300 Kelvin. So temperature will now be in Kelvin, will be 4 dm cube times 300 Kelvin over 2 dm cube. Dm cube cancel dm cube, 2 here 1, 2 here 2. It now gives you 2 times 300 Kelvin, give you 600 Kelvin. So that's how you calculate it. This is the second one, we have already tackled it. Look at the first one very well and go through what I've just solved. In the second one, remember we are looking for the temperature when the volume is doubled. This is how you solve it. By using 2 to times the final volume is, when the initial volume is doubled, use 2 to times it, meaning you have doubled it. So that's how we solve it, my amiable viewers. Please, if you are not subscribing to this channel, kindly subscribe, because we are going to be bringing more and more questions, so many, so that by the time you are able to understand this, who knows, many of these will be repeated in your external exam. Thank you very much. God bless you.